Hey everybody, my name is Ben Teese. I work for Shine Technologies and I'm here to give you a little bit of an introduction to React Native. Just a quick warning up front, there's going to be a lot of JavaScript in this presentation. You don't really need to know a huge amount about React because I'm going to be starting with its core concepts, but it will help if you know a little bit of JavaScript. The agenda of this presentation is going to be covering these React core concepts up front because I think it's important to understand them before we get into React Native. Then we will start talking about React Native and how those concepts translate to the native development world. Finally, I'm going to present an example and do a bit of a code walkthrough, and in doing so try and get you familiar with the way that React Native works. Okay, so let's start talking about React. I saw this funny picture on Twitter a couple of weeks ago, and I think it summarized sort of the JavaScript framework world really well. The JavaScript ecosystem or community is notorious for coming up with new JavaScript frameworks and getting very excited about them. My involvement with JavaScript probably started around 2012, 2013, when Backbone was very hot. And I think Backbone deserves a lot of credit for bringing MVC to mainstream JavaScript development. However, Backbone, there wasn't actually that much to it. You would kind of subscribe to views from models. You would have views subscribe to events from models. You would update models from view events. But you had to wire all of that together yourself. And then Angular kind of came along, and Angular did that automatically. Angular included two-way binding, and that certainly saved a lot of code. Angular, however, demonstrated that it was hard to implement two-way binding correctly, at least using a standard kind of event-based approach. And that even made writing custom components a bit difficult. Then along in 2015 came React, and although I'm certainly not claiming that React will be the last of the JavaScript frameworks, I do think that it's got some ideas in it that are genuinely different from the MVC frameworks that have preceded it. In fact, React isn't really an MVC framework, it's really just a view layer, but it draws upon some very big differences in order to revolutionize the model that you use for writing your user interfaces. So there are three core concepts of React that I'm going to talk about for starters. The first is the virtual DOM, which, whilst in some ways it's an implementation detail, it has such profound implications for development that I think it's worth understanding. Secondly, we'll get into React's idea of having declarative components and JSX and so on. Finally, we'll get into React's encouraging people to write their applications using one-way data flow. React does not do two-way bindings, it just does one-way bindings by default from models to views, and that also has some implications when it comes to being able to write easier to comprehend and understand programs. All right, so let's start with the virtual DOM, and I'm going to sort of start with a very simple example, so apologies to those web developers who are already familiar with the concepts that I'm going to be covering. Let's say that we have a really simple little website, and the sole purpose of that website is to gather email addresses. You know, people can go to that website and enter their email address and submit it. I've obviously implemented the world's simplest website here. There's not even any bootstrap styling, it's just some plain markup. But this will be a kind of handy way for us to get our heads around the idea of the DOM and the virtual DOM. So this website will have some HTML behind it. The HTML that we're concerned about is really just this div with a heading in it and a form, and the form's got a field and then a submit button. Now, when the browser parses that HTML, it assembles it into what we call a document object model. And that's what the browser uses to render what we see on the screen. And it's really just a hierarchy of objects. Now, if we wanted to change what's on the screen, the way in which we'd go about doing it is we would mutate our HTML. So we might add a new div to it. It's just got a message inside of it. And normally or traditionally, when it comes to actually making this change dynamically, we put a new element directly into the browser DOM. And this is actually quite an expensive thing to do, interacting with the browser DOM, because as soon as you do it, you force the browser to do a reflow, a repaint. Even reading from the DOM can be expensive because sometimes it has to do some calculations in order that you can read accurate values. So traditional frameworks have all done direct browser DOM manipulation, but that kind of ran into or caused a lot of problems and had implications. So what React decided to do differently was to say, well, what if we could effectively re-render the entire DOM every time? Obviously, doing that into the browser DOM would be very insanely expensive. So React said, well, what if we just rendered it into a virtual DOM in memory? Every time something happens or an event gets handled and we need to update what's on the screen, we first write it into this virtual DOM or create a new copy of this virtual DOM. And then if we need to mutate it again, we make a change to the virtual DOM. And then what React does is it assembles a diff of what the difference between the virtual DOM and the browser DOM is. And then in one hit, it applies that diff as a patch to the browser DOM. Now, if we're just adding a single element, it's not such a big deal. But if you're adding lots of elements or changing lots of attributes, batching them up into one hit is hugely beneficial just from a performance perspective. And the virtual DOM, even though it is a duplication of this object model, because it's just JavaScript objects as opposed to a full-on browser DOM, it doesn't even have that much of a memory overhead. So that's the first big concept behind React. Let's look at the second one. And this is sort of something that comes out of the implications of being able to very quickly and easily re-render your entire UI from the developer's perspective. And that's this notion of declarative components. So let's jump straight into some React. Let's say that we wanted to make it that this sign-up form is a part of a single page application. Here's what the React component might look like. It's a class, an ES6 class, that extends from a React component base class. Every React component has a render method, and all that does is return the portion of the virtual DOM for that component. This is where things get a little bit funny, because we've got HTML here embedded in our JavaScript. And when this was first when React was first announced and this technique was proposed, it was hugely controversial in the JavaScript community. Because this isn't actually a JavaScript file, it's what's called a JSX file. It's mostly JavaScript, but with some fragments of markup embedded inside of it. Probably the first thing, though, to know about JSX is that all that React really does is compile it down to JavaScript. So if we take this render method of ours, all that React does is convert it to this JavaScript. It assembles a tree of plain JavaScript objects for them. It just instantiates all of those objects. It maps the HTML markup directly to creating a whole bunch of element objects and assembling them together. JSX also has a notion of expressions, so we can embed dynamic stuff inside our markup. So in this case, we might have a message variable, and then using this curly bracket notation, we can embed that message's value into the markup. And again, when this is compiled from JSX to JavaScript, there's not a huge amount that's magic about it. The JavaScript just ends up looking a bit like this. It's still got a variable declaration at the top, and then as it creates elements in the DOM tree, or the virtual DOM tree, it just inserts that message content to be the body of a div. You can also do some other cool stuff with JSX. You can create very easily and cheaply your own nested components. So here's an example. Say that we wanted to make it that our little message is displayed by its own component. So we're going to create a component or define a component called message, we're going to pass a value into it that is the value of our message variable. And that's how we do it. That value is just a property. Our message class is down here. It is also a React component. It has a render method. And that render method returns some markup that contains that is the div. And most importantly, we can get access to the value property that was passed in by using this props object. The props object contains all properties that were passed into the component when it was instantiated. Okay, so the last big React concept is one-way data flow. And what we're going to do is demonstrate with an example. So the sample page that we've seen so far is obviously doesn't do much. Okay, let's make it dynamic. Before we do, I just want to give you a very quick overview of sort of the basic process that React goes through when it's handling an event in the event loop. There is no automatic two-way binding, so updates to views do not automatically propagate to models. We have to subscribe to event handles, to subscribe to events ourselves. So whenever an event comes in, we handle that event. The next thing that a component does when it handles an event is update its own state. And we'll get a little bit more into exactly what that means in a second. In updating its state, the component is then marked as dirty, and so towards the end of the event handling loop, the component will re-render all of itself and all of its children too. Finally, React will reconcile the new virtual DOM against the browser DOM and update it accordingly. And then we rinse and repeat for the next event that comes in. Let's look at a more solid example. Say that on our sign me up form we want to keep track of what the email address is because we're going to want to send it to the server soon. How do we do this? Well, we'll go to our input for that email address field and we're going to bind it to a value. We're going to set a property called value, and that is a property called email address on an object called state on the component. And a state is a special object. State encapsulates the mutable state of that component. React encourages us to keep it as small as possible and as localized as possible. Because our email address will be changing over time, the state object is the place to put it. Initially, because our email address is undefined on the first render, because we're setting the value to be undefined, no email address will be in the field. The second thing we're going to do is add an event handler. We're just going to say that whenever the value in this input field changes, we want to call our little change handler function. Our change handler function's down here, method's down here. It calls another important method called setState. And it passes setState, an object with that email address. setState merges the object that's been passed in into the current state for the component. It also marks the component as dirty, which means that React is going to get that component to re-render itself and all of its children. So if I was to sort of walk through this cycle, a handle change event goes from the input up to the sign me up component. It calls setState on itself with the email address. And the sign me up component says, right, I'm completely invalid now, I'm going to have to re-render myself. First thing it does is create its top level div, then it's h1. It's going to display its message div, then its form, this div here, a label, an input that is passed the value property that is the email address so that it can render the email address inside the input. Then it's going to put in the last of the DOM components. So that was an example of one-way data flow in action, but let's do another example. Let's go through what happens when we click the submit button. We're keeping track of the email address now, but what happens when we click submit? Well, the first thing that we're going to do is we're now actually going to introduce a second state variable called message. Message by default will be undefined, so when the page renders for the first time, there will be no message displayed. Second thing we're going to do is make it when the form is submitted, then a submit handling method gets called. That method is defined down here. Now, what that method does is it gathers the email address that's set into the current state, the current email address that's set into the state, and it posts it to our back end. Now, fetch returns a promise, and for those of you who mightn't have worked with promises before, a promise is just an object that represents the eventual state of an asynchronous operation. And promises are kind of cool because you can register callbacks to be invoked whenever that asynchronous operation finishes. And we register callbacks using a method called then. So on the promise, we're going to call, if it's returned by fetch, we're going to call the then method, and we're going to pass it a little function. And that function calls setState with two things. Firstly, it clears out the email address, and then it sets the message. Now we know what happens when we call setState. So that our form calls handle submit. The sign me up component calls setState on itself with a message in the email address. Because setState's been called, the entire component needs to be re-rendered. And it starts re-rendering itself. The div gets called first and the h1. The message gets called, this time with a value of thanks. So it creates its own div with that value. The form appears, or is written in, then the div, the label. Our input is written out again. This time it's passed a value property that is an empty string. And finally the last of the components are rendered. Now an important thing to note about all of this is that the mutable state is only kept in the sign me up component. It passes down values to the message component and to the input component. But those values are just properties. They're just read-only. The message and the input don't mutate their own properties. They are, however, re-rendered every time that event happens, which normally would be a crazy thing to do. But because React Native is able to efficiently render changes to the actual browser DOM, we can throw away the whole tree and render it in the easiest way possible, which is just to render the whole thing, instead of having to poke into particular components and update them. So the end result of this is that we can enter our email address, click submit, and it pops up a message for us. So I'm going to just re-emphasize this whole loop that React uses one more time. We handle an event, component updates its state, it re-renders itself to the virtual DOM and all of its children. The entire subtree gets re-rendered, passing properties down from the state as needed. And then finally, React takes care of reconciling the new virtual DOM with the browser DOM. And then the process gets repeated on the next event. So we've seen three important concepts of React. We've seen this idea of the virtual DOM, this notion of declarative components described using markup in the simplest way possible. And we've seen this concept of one-way data flow, where instead of having to peek into components and poke new values into them, we essentially flow changes down the tree whenever they occur. So an event is handled at the highest point in the tree that makes sense, and then that tree re-renders itself with all new updated values. That's React in a nutshell. So let's move on to React Native, the part you've all been waiting for. React Native in a nutshell has all of the same core concepts that I just described as React. It's still JavaScript as well. Those core concepts don't necessarily need to be implemented in JavaScript. So for example, Facebook, which invented React, have also ported React to Objective-C. It's called Component Kit. However, there are some benefits to still using JavaScript in a native environment, and we'll talk about those a bit more in a second. Finally, and this is a really important point to emphasize, in React Native there is no UI web view, there is no actual browser DOM. Okay? And this makes React Native a little bit different from frameworks like Cordova or even Ionic, because they all use UI web views. They use standard CSS, HTML, and JS inside a web view. React Native's not doing that. It's using Cocoa's core JavaScript engine to run its JavaScript, but everything else is native. The way in which React deals with this virtual DOM, React Native deals with this virtual DOM concept is that instead of having a virtual DOM, we have a virtual view hierarchy. And when we make a change or add a new element to our virtual view hierarchy, React Native looks at the diff between the actual view hierarchy and the virtual view hierarchy, assembles a patch, and applies it to the view hierarchy at the end of the event loop. That's the only real difference. The React model isn't specific to the web. It can be applied to other view technologies as well, and React Native demonstrates that. Now, you might have been looking at that tree and wondering, well, what are those different components? And React divides them into two different categories, I think. React Native aims to draw the best from the native world and the web world where it makes sense. So there are a bunch of iOS-specific components, sliders, switches, and so on. However, for things that are kind of text-related, React has a more generic set of components. There's a view, which is kind of like what a div would be in a browser, just a component, just a container component for storing other components, a container that stores other components. Then there's also components for displaying text and editing it. And for those sorts of components, React Native's gone with a model of actually styling them via CSS. And you'll see an example of that a little later on. Same with images and so on. The iOS-specific components, you can set native widget properties on them yourself. The generic components, you generally are more kind of text-based or image-based, and you use a sort of a pseudo CSS to style those. You'll notice that the navigator appears twice in this list. React Native comes with both an iOS-specific navigator and a generic navigator out of the box. Facebook's built a couple of apps in the App Store already with React Native. The Groups applications has portions that are built with React Native, because one cool thing about React Native is the whole app doesn't need to be React Native. You can actually just have certain components on your screen that are React Native components. And an app that they've built that's entirely created with React Native is their Ad Manager app, which people use for managing their ad campaigns on Facebook. Both of these are in the App Store. So how do you get started with React Native? Well, React Native is built with Node. So the first thing that you want to do is install Node and use the Node package manager to install the React Native client application. Second thing you're going to do is use that React Native client application to initialize yourself a new project. When the React Native client creates that project for you, it's kind of like a skeleton of the project, and part of that will include an Xcode project. So all that you need to do is open up that Xcode project. Now, you don't actually have to mess with much in this project unless you want to add like custom widgets and things like that and bridge them yourself from React Native. But in this talk, I'm really just going to focus on the out-of-the-box React Native experience. And really the only thing that you need to do in that case is run your project. What will happen is that your simulator will pop up and it will already be displaying a little bit of text, and this is your kind of bootstrap React Native application. There's a couple of interesting things to see here. Firstly, it's pointing you to a file where you can start editing your app. It's just a JS file. It's not even actually in the Xcode project by default. It's sort of at the root of the tree you created with the React Native client. Second interesting thing is you can reload the app in the simulator dynamically without a recompilation step. This is one of the powers of using JavaScript for this sort of thing. Finally, if you Command D, then React Native will give you a little pop-up menu. And you can use that for debugging and monitoring frames per second on animations and stuff like that. So I'm just going to show you a little video that kind of demonstrates how this live reloading works. So we've got a little skeleton app here. We're going to change the title that's being displayed welcome to my new project. We'll save our file just in Sublime Text. We'll go to the simulator, reload it, and there the text is updated automatically. No compilation step required. Just in case you're wondering, the index.io.js is in the root of the project that's been created for. It's not inside the Xcode project. Obviously, it's a very, there's not much to that example. So let's say show you something a bit more substantial, and we'll walk through some of the, in doing so, we'll walk through the code and try and get our head around the way in which React Native does things and the way in which you piece together an app. So I'm not sure if you're aware, but in JavaScript land, whenever a new JavaScript framework comes out, which is pretty much every week, somebody will write a version of a to-do list app using that new framework, and they're all uploaded to one kind of catalog site. I think to-do lists are cool, but I personally prefer to keep a list of things not to do. Maybe things that I've done before that I really don't want to do again. So if I've got a little bit of spare time, I can always just peruse my app to remind me of things not to do in future. So I'm going to call this my To-Don't app. And here it is running in the simulator, and I'm just going to open it up and take it for a spin. This is all written with React Native. We'll crank up the app. It's got a list of things not to do that I've added. Top of the list is treating Guinness as a meal substitute. So I've been out drinking with friends in the past. We've been drinking Guinness, and it gets to a point in the night where I'll go, hey, you want to go get some dinner? And someone will look at me and go, we don't need to have dinner, we're drinking Guinness. And I go, okay, and I feel terrible the next day. I've done it before, so I can rate how bad it was when I did it. I can also add new items here, so I have 2 small children, and they're quite close together, and that's something I highly recommend not doing. So here I am, I'm going to add it into here. Yes, I've also done that before. I'm going to rate it as, pretty bad. Pretty life-altering. And then I might have second thoughts and go, you know what, let's just generalize this thing not to do to just be to not have children full stop, because yes, I've done it and it was pretty damn bad. And of course, I'm just joking around here, so I can delete items from my things not to do list as well. So that's my app in action. Now, just a quick one, a friend of mine looked at this app and said, gee, those colors are like the Facebook site. If you use React Native, do you have to use Facebook colors? And that is definitely not the case. In fact, I don't use Facebook, so I carefully set up this color scheme for this app and override all the default colors for iOS, and yes, had no idea that I was setting it to Facebook colors. So don't worry, you don't have to use this color scheme if you don't want. So let's have a look at the code for this app. And the starting point is index.io.js. What does that look like? All right. In React Native, all of your files are common JS modules. So you bring them in using the require syntax. So I'm going to bring in the key React module, plus I'm going to bring in a custom module that I've written myself. All modules you see that start with TD are modules that I have written myself. They are To-Don't application modules. And you're going to see a lot of them, because React kind of encourages this approach. I'm going to grab a few classes out of the module, the React module, and I'm going to declare a class for my app. It is just a React component. It's got a render method. That render method is going to return some markup. Now, instead of HTML, it's just going to return some XML that uses some of these React Native components. In this case, I'm going to use the Navigator iOS component. This gives us sort of back and forth navigation to slide between different screens. Initially, I'm going to get it to display my list container. We'll get to the code for that in a second. I can also set properties, iOS properties directly on that component, so I can set the color of the bar and so on, and all sorts of bits and pieces. However, there's also this property here called style, and even more intriguingly, it's set to flex. So what does that mean? And this is where I do the next big controversial thing about React Native, and that is that it does layout using Flexbox. Flexbox is a modern layout algorithm for use in web pages. It's sort of a quantum leap over the way we've traditionally done layout with the web, and it's certainly sufficient for doing layout of React Native applications. In this case, I'm just setting the flex property to 1. All that means is the first child, or that this component within its container should, being the first child, should expand to fill up all of the available space, which indeed it will do. The decision to use flex for layout is kind of certainly a surprising one, but I think it's sort of part of the vision that the React Native team have to sort of take the best of the web and of native and combine them together, and also to do it in a way that can potentially be cross-platform in future. Finally, we're going to register our component just so that with our app, so that React Native knows what component to start up when the app starts. So let's drill in a little bit to this and look at the TD List container class. This class contains the list at the top and the new button down the bottom. What does it look like? Well, it contains a simple view. Again, that's just a container for other components. It's customary with React Native to style components or to externalize styles just in a separate object. It's still in the same module, so it's hidden, but we don't put it inline in the markup because it just makes it too messy, really. In this case, our style variable is down here, and again, it's just setting to expand out vertically. Next, we're going to have another custom component that displays our list of objects. We're going to pass that list of items, we're going to pass that list of items into the list. It's stored in the state of the list container. That's so that the container can listen for events and, for example, an item being opened or so on, and take action accordingly. Finally, we've got a little custom component here for a button. It's in a component of its own just because my buttons all kind of look like the same. I want the styling and so on to be in one spot. Okay, let's look at the list now that I've written. It starts off with this data source at the top. This is just a way to map an array of objects into something that a list view can interact with. The list view is a component that is provided for you out of the box by React Native. React Native does not use UI table view out of the box, although there are wrappers for it that you can use. However, for simple usage, list view is often enough. List view takes our data source, and it also takes a function that is used for rendering each row. It passes to that function the data for that row and a row ID and so on. In this case, we're going to render another custom component called a list item, and we're going to pass it that row data. Drilling into the list item here, a couple of interesting things. In our markup, we have what's called a touchable highlight, and this is sort of the simplest way in which React Native lets you deal with touch events. React Native doesn't actually even have the concept of a button or anything like that. All that you do is create a touchable highlight, which is just a space that will detect a touch and provide some sort of visual indicator in response. And inside that text touchable highlight, in this case, we're going to put a text field. So the text field's got some special styling of its own. In this case, we set font sizes and so on. So this is another case where you have React Native gives us a component that is a little bit more webby in the way that you deal with it. Now again, under the hood, it's not actually using a UI web view or anything to render this component. It is using native technologies. It's just that React Native have sort of subclassed UI view and so on, and given you a mechanism to display text that's more in line with a web way of thinking than anything else. Finally, let's take a look at this TD edit class. This is sort of the one that encapsulates a page where we edit a ToDo item. There's a few things on the page. I'm just going to focus on this little switch here, where when you switch it, it sort of pops open and displays this slider. What does the code look like for that? Okay, so we've got a label here. All my labels kind of look the same. Again, I'm trying to keep the styling in one place, so I put them in a tiny little lightweight component of their own. Underneath the label, we have our switch. This is a custom iOS switch, and it takes a value that is set to a state variable. What we then do next is we look at the value of that state variable, and if we have set that if the switch has been flicked, then a custom severity component will be displayed. Otherwise, we'll just display nothing or an empty view. Finally, drilling into our severity component, again, it's got a label in it. We can reuse these components as we see fit and their styling. It's got a little view up the top where we display these labels on the slider.
that's styled accordingly. Again, we're using Flexbox to lay out those labels. In this case, we're saying we want to have them lined up horizontally in a row, and we want them to be justified left and right. Finally, we put in our native slider down here. It's bound, note here, to a value property that's been passed in. So again, this is a case where when you change a value on the slider, for example, it will notify the parent TD edit that the value's changed. The TD edit updates its state and then re-renders the slider. But just with it, from the slider's perspective, it's a read-only value. Normally that would be an insanely inefficient thing to do, but because React again is reconciling against the actual view hierarchy, it only changes what it actually needs to on each event loop. So next thing we're going to look at is animations. So going back to our app, we've got this little switch, and originally I was just kind of flicking it and things would pop open and closed, and it was all pretty jarring. What we want instead is for there to be a nice smooth animation when these things pop into place. So how do we do that? React Native has got its own whole animation subsystem of its own. It's extremely, to my mind, it seems to be quite comprehensive. For a very simple animation like this, it's almost embarrassingly easy to do. So React Native gives you a convenient way to animate layout changes that are going to happen after you've handled an event. So in this case, all we're doing is saying, look, the next layout animations that occur, whatever they are, should be done using an ease in, ease out style transition. Then, we set the state that will cause a layout change to happen, and React Native handles the rest. One other important point to make about React Native is that because it's using JavaScript under the hood, everything's pretty much asynchronous by default. You don't really have to worry very much about your UI getting blocked because you're doing something, say, against a backend or something like that. So if I was to take the TD list container or revisit the TD list container, let's look at how it might load data from a backend. A good place inside the TD list component to do this is in the component didMount method. This is a special method that, if present, React Native will call for us when a component has been sort of mounted into the virtual tree for the first time. It's only called for the first time the component is rendered. If it happens to be rendered again and again, it won't get called. It'll only get called once, so it's a good place to fetch some data. We're going to use the fetch API again to get our data for us from a particular URL. We might provide some headers or something like that to identify ourselves. Again, fetch returns us a promise, and the fetch API is actually quite an asynchronous one. So it's kind of a replacement for XML HTTP request in the browser, and it's also available inside React Native. When we fetch something, it gives us a response, but it doesn't even actually start reading the content of the response yet. It gives us a chance to decide if and when that's going to happen. So in this case, we're going to say that we want to start reading the response JSON. But that gives us another promise in turn that will only resolve when all of that response JSON has been returned. So we chain on another promise block to get to that JSON. The JSON is a string, so we're actually going to parse it into a plain JavaScript object. Then we're going to get the items variable out of it. And we will then finally call setState, and that will cause the container to render itself with all of the new list items. And the cool part of this about it is it's all asynchronous. The JavaScript is not going to block at all. Your UI is not going to get blocked. And it sort of does it out of the box, which for user interfaces I think is a really important thing to do. One other thing that I'd like to talk a little bit about with React Native is touch handling, because one thing that the native world certainly does better than the web world is giving you a good API and a very powerful API for intercepting touches. So, in the native world, you have this whole kind of responder chain that you can, opt to pick up touches or allow them to go through down the chain, and it is very powerful. It was a little hard for me to think of a way to demo this in the app, but what I'm going to do is provide a means where if we just swipe up and down, the bottom of the edit page, then it just automatically pops through to the next item in the list. Can't swipe left because it'll take my navigator back, but up and down, let's say that we want to use those to move through our list without having to go back to the main screen. So how do we implement this? Well, we're going to create a new component, custom component called TD Swipeable, and we're just going to pop it down here. It hasn't actually got anything in it. We're going to put it at the bottom of our edit screen, and the way in which we do that is just declare it down here at the very bottom, and we're going to make it that it takes two callbacks, one for handling an up swipe and the other for a down swipe, and they just will show the next item and the previous item. So how do we implement this TD Swipeable component? Well, as I mentioned, the touch handling in React Native is very powerful, and it kind of gives you some helpers for dealing with simpler cases. And this is actually a simpler case because all we're really doing is looking for kind of like a sweep, you know, a sweeping touch, and it gives you something called a pan responder to deal with that. The pan responder really just sets up a bunch of special properties for us. It's a shorthand way to set up a bunch of special properties for dealing with a panning event. In this case, we're saying, yes, we do want to respond to this sort of touch event if it kicks off. And when a pan movement happens, we're going to see if it's panned up 100 pixels, and if so, we'll call that an on up swipe. And if they pan down 100 pixels, then we'll call it a down swipe. Then all that we need to do is take the properties that are generated for us automatically by the pan responder and pass them into the view, and that's pretty much it. It will deal with detecting those swipes and calling our appropriate callbacks. So there's one final thing that I want to show you before I finish up, and a couple of days before I did this presentation, React Native for Android was announced, and it's at a very early stage. And well, actually, it was more than announced; it was released, and it's at a very early stage, as in React 0.11. So I just thought I'd have a quick stab in, spend a couple hours trying to get my app running inside React Native and let you know how it went. Before this point, I'd never done any Android development. I didn't even have the Android SDK on my machine. So here's the app running in the Android simulator. So we can scroll up and down as per usual. We can reload using the same sort of developer tools that we saw with iOS. Now things start to get a little bit curly once we click through to an event. First thing is there's this funny color with the text editor, and it was difficult for me to know how to change that, at least very quickly. Same with this switch here. Even worse at this point is that the slider, there is no real slider component for iOS native Android. There probably will be one in future, but it was a bit of a deal breaker for me. I was going to have to implement one myself, unfortunately. So that's as far as I took it. It's not a bad start. Probably the biggest change that I had to make to the code base for the iOS app is switch from using a native iOS widget to using the generic, so the native iOS navigator widget through to using the generic navigator widget, which is kind of coded differently. It is coded in a kind of more React-friendly sort of way. It wasn't actually such a big deal shifting to that widget, but the interesting part was that React Native for Android by default styles the navigator using material design guidelines, and at least in this app that looked pretty bad, and my options were to either force the navigator to be styled more like an iOS app, or to kind of restyle my entire app to be more in line with material design. I went with the first option, and I had to do some pretty nasty things in order to achieve that. I definitely would want to qualify, this is what I've done so far, just with the caveat that React Native isn't intended to be a write once, run anywhere framework. Across different platforms, you want to consider the best UI paradigms for those platforms. React Native aims to give you a mechanism for easily coding across those platforms, but it does not have a stated goal to allow you to reuse the same code. And I think I began to see, how that would be the case when I ported this app across. So that pretty much finishes up my talk. If I had to summarize React Native just in a few words, I'd say that it's kind of native technology, but using a lot of web techniques, or at least what the Facebook React Native team have deemed to be superior web techniques. And their ultimate long goal with this is what they call a learn once, write anywhere approach. I think it's too early to say whether this is really going to play out. We've dealt with write once, run anywhere in the past, and all it's really left us with is apps that look equally bad across all platforms. Learn once, write anywhere, the goal being that developers only have to learn one framework and then can build native apps using that framework without having to learn a completely different skill set. It's an interestingly ambitious goal, but I think it's too early to say for sure whether it's going to play out. One thing I think for sure, though, is that even if you don't use React Native, the programming model that React has is an extremely compelling one. This idea of having declarative components where you don't have to, you can just say how they're rendered at a point in time based upon state. You don't have to worry about mutating parts of them or poking into them and stuff, and letting the framework take care of rendering that efficiently. That's extremely liberating as a developer and enables you to write code that's just easier to understand and reason about. I think it's a really compelling programming model and one that we're going to see more of in the future. Thanks very much for your time, and I hope you get to have a bit of a play around with React Native.